Hello, everybody. So what we're looking at today is the exam 3 practice problems. So just a reminder for those of you who are not aware that the real exam should be open. I'm thinking I'm going to open it on Sunday. Real exam open Sunday to Friday. That way you have an extra day. Sunday's a weekday, that's why. Otherwise, you can do it anytime, Monday through Friday, and submit it online. So remember, it is going to be an online test, the real exam, online, and multiple choice. So it's not quite like this. And also, these problems are, there's more of them here than there will be on the real exam. With that said, let's go right in and get started here. So we're going to be looking at exponential and logarithmic type problems, and then also solving systems of equations. And I'll show you several ways to solve the problems that have several ways to solve them. But let's get going. So what we've got here for our first problem is f of x equals 3 to the x minus 1. This is an exponential function, and we want to calculate the following values. This is just to make sure that you can understand what an exponential function is and calculate it here. Feel free to use a calculator if you need to, right? So let's go. So first thing we're calculating is f of 1, so we'll plug a 1 in for x. So we'll have 3 to the x minus 1, which is 1 minus 1. And then the exponent 1 minus 1 is 0. And then anything to the 0 power is 1. So 1 is your answer. 1b is the exact same process. So we're going to plug a 3 in for x. So we'll have 3 to the 3 minus 1, which is 3 to the 2. And of course, 3 to the 2 is 3 times 3, which is 9. Just like that. Okay. Our next problem is similar conceptually, but you will need a calculator to evaluate this. And also the key to problem 2 here is understanding that this right here needs to be evaluated separately from the 820. So like what you want to keep from happening is this. Like when we're calculating f of negative 10, f of negative 10 is 820, 0.92 to the negative 10. Okay. You do not multiply these two together, right? The 820 and the 0.92, that's wrong. Okay. What you have to do is the exponent first, because when you're looking at order of operations, you have parentheses first, then exponents, multiplication, division, addition, and subtraction. So we have to do the exponent before we do multiplication. So you can't multiply these two numbers together first. What I would recommend you do here actually is evaluate this entire thing by typing it in all at once into a calculator, which I'll do now. So 820 times 0.92 to the negative 10 exponent, and it's 1887.7. Just going to round it there. We have to round it somewhere. Might as well be there. Okay. Now, if you're going to use a computer because you don't have a calculator, that's fine. I'll just use Wolfram Alpha as my calculator. So we have, what was it? It was 820 times 0.92. You can put that in parentheses if you want, to the exponent negative 10. So notice I'm using parentheses around the negative 10 to make sure that the negative 10 is all included in that exponent. So that's it. That is the answer, 1887.7, as you see. So f of 10 is going to be the same way. We have 820 0.92 to the positive 10 this time. And we can just go right back over here. Oops, I clicked the wrong button. We can just go right back over here and change that exponent. So 356.2 if I round it. 356.2. Just like that. So, if you have a calculator, make sure you can type it in correctly. And that's about it. So then we have a couple of word problems involving compound interest and also population growth. So compound interest is probably one of the more complicated things that we've had to calculate in this class. I've printed the formula for compound interest right here. Really the key here is just knowing what all the numbers are. So you would want to know, like, R, for example, is the rate, but interest rate as a decimal. And if we read this problem, it says here, the account earns 3% interest. So this is the interest rate, 3%. But as a decimal, 3% is 0.03, right? You have to move the decimal place from here over 2 spots to make it a decimal. So 0.03 is the interest rate. Also, we have N. N is the number of like compounding periods per year, basically. So if we're compounding monthly here, compounded monthly, then N would be 12. If we were compounding quarterly, N would be 4. But in this case, monthly, 12 months in a year, so 12. Quarterly, 4 quarters in a year, so 4. Right? Daily would be 365, and so on. So N is 12 in this case, and the A0 is the initial amount in the account. So the initial amount in the account. Now, if you're not paying attention, you might think that 5,000 is the A0, but it's not, because look, it says how much would you need to deposit. That's actually the A0, the amount that you need to deposit. How much do you need to deposit in an account now in order to have 5,000 in 15 years, right? So this is the amount we end up with, not the amount that we start with, right? So the A0 is the initial amount in the account. We don't know that. The A in this case, we do know. We want to end up with 5,000. But that's on the other side of the equation there. And also T is time. And for this specific scenario, we were told that we were waiting 15 years. So the T is going to be 15. So we fill in everything that we know into this formula here. And we'll have, right, this formula. So A is 5,000. The A0 we do not know. So I'll just leave it A0. Then we have 1 plus 0.03, that's the R, over N is 12, to the NT, which is 12 times time is 15. Like that. Okay, so what we need to do now is basically this part right here. We need to evaluate that. So we'll just do that in Wolfram Alpha. You could use a calculator, of course. Let me just do this so we can type it in and see it at the same time. So the part that I highlighted is all I'm going to type in. So I've got parentheses 1 plus 0.03 divided by 12, close parentheses, and then the exponent is open parentheses, 12 times 15. 12 times 15, close parentheses. So you can see there that that's 1.5674, etc. I'm just going to go ahead and write that out. A0, 1.567443, etc. Right? Big number, but I'll just stop it there. Okay. If we're trying to solve this for a sub zero, which is the initial starting amount of money that we had, our next step would be to divide both sides by that 1.56743. So the A0 should be 5,000 over 1.56743. Or if I'm being lazy, I can come over here and just say 5,000 divided by that. And you can use parentheses just to make sure that you actually are getting everything in the denominator there. So I could have typed that in manually by hand, but being lazy, so I just did what I did. So what is A0? It's the answer here. It is 3189.93. That's how much you would have to deposit to end up with $5,000. If you were going to round it, you could say 3190. But I'll just write it that way. With money, a lot of times you either round it to the nearest dollar or you do dollars and cents, right? So that's why I did 2 decimal places here. So it would be cents. So anyway, 3189. So what that's saying is, back to the problem, how much do you need to deposit to end up with $5,000? Well, you need less, right? We'll end up with $5,000 if we deposit 3189. That's the idea. Okay, so that is compound interest. Next question. Next question is going to be similar but easier. You'll notice that the formula for population growth here is like the formula for compound interest, but there's no n to worry about. So that makes it easier. So let's go ahead and get started here. So in this case, we have P0, that's the initial population. They say 5.74 billion, but we can just write 5.74. The growth rate, so we still have an R, but it's a growth rate instead of an interest rate. As a decimal, though, that is also still true. So the R is going to be 0.0143, right? You still have to move the decimal place twice. It's easy to get that wrong. And that's it, right? So what happens here, try not to sneeze, hold on. Okay, so if you fill in the P0 and the R just in this equation, you have P equals 5.74, 1 plus 0.0143 to the T, right? And you can actually simplify that a little bit before we even start the problem by adding the 1 and the 0.0143 and get 1.0143 to the T like that. So this is a good place to start. That's not actually the answer to the question. The question actually asks here, what are we looking for? So population in 1995 was 5.74, okay. The annual growth rate's 1.143, that's reflected here. Assuming the world population follows an exponential growth model, that's what we have. Find the projected world population in 2005. So from 1995 to 2005 is 10 years. So what we need to do is evaluate this with t equals 10, and we'll get our answer. So the population, when you put in a 10, is 5.74, 1.0143 to the 10. You punch that again into a calculator. I'm not going to go over to Wolfram Alpha. I'm just going to type it in right here. My calculator, 1.0143, close parentheses, to the 10th power. And I do this and I get 6.6, let's say 2, 10. And that would be in billions of people. Right? So does that make sense? So if it had been something more complicated than 2005, I would have had to figure out how many years from 1995 to 2005. In this case, it's easy to see that that's 10. But, if it was like 2017, you'd have to think a little bit harder, but still pretty easy. So that is our projected population. All right. So we have a logarithmic form and exponential form here. So problems 5 and 6, they just involve the conversion from one to the other. So, I mean, you can write this a lot of different ways. So I'm probably going to mix up the variables compared to where you've seen this before. But basically this, if I say like log base b of x equals y, that's log form. And exponential form that says the same thing would be, well, the base is still b, the base is b, the exponent is y, and then this is going to be the result. So b to the y equals x. So it's just asking you to rewrite log form to exponential form or exponential form to log form. So in this case, for example, where we've got 3 to the 4 equals 81, that would be log base 3, right? Base 3, because the 3 is where the b is, right? If this is where the 3 is, so this is where the 3 is. Then the number that goes here is the one that's on the opposite side in exponential form. That's the 81. So log base 3 of 81 equals the y. The y was the exponent in exponential form. Exponential form, exponent was 4. So you're just mixing up where the numbers are, right? So 3 to the 4 equals 81. 3, 4, 81. Kind of think about it going like this. So here, same thing. If I just do this one quicker, it's going to be e to the x equals 7. This would be log base e of 7 equals x, right? With a variable there, it's harder to understand maybe, but there you go. Now, the problem, not problem, but also, keep in mind that log base e is also called natural log. So you could say natural log 7 equals x. Either one of those would be fine. Okay, now problem 6 is the exact same thing, but the opposite order. So in this case, you're going to start with the 7, go to the 2, and then to the 49. So exponential form will be 7 to the 2 equals 49. And, you just compare these two here, and you'll figure out how to write it. Next one, ln 100 equals 4.6. That's actually approximation. But what this is saying is, this is log base e, remember, right? Log base e, even though it doesn't say it, e to the 4.6 equals 100. That's, again, it's actually only approximately equal, so it's not exactly equal, but I'm just writing this. Okay, problem 7. So problem 7 involves the log property, basic log properties. Basically, this property here is important. When you do like log base b of, let's say, b to the, let's say a, the log and the exponential cancel out and leave you with a. Also, it's not relevant here, but if ever you do b to the log base b of a like that, they also cancel out and leave you with a. That's the main identity you need for both of these, but also I threw this one in. When you do a log, any log of like 1 over a, remember that that's the same as negative log a. Or actually, I don't want to do that. I lied. We're not using that one. I just want this. Remember that like 1 over like a to the b is a to the negative b, right? So an alternate way to write this fraction is with the negative exponent. So let's come over here and apply that. So log base 6 of 1 over 6 to the 5, I can rewrite that 1 over 6 to the 5 as 6 to the negative 5, right? That's using that last property that we just looked at. And then once I do that, what I know is that the log base 6 and the exponential base 6 are going to cancel. And my answer will be negative 5. All right. And the reason I said exact answers, not decimals, is because I don't want you just typing this into a calculator. I mean, I guess Wolfram Alpha will give you the right answer no matter what, but still. All right. Next one, log 1000. So there's a couple things here that that would make this easier if you happen to know them. First is log base 10, right? If they don't say it, it's log base 10. So that's log base 10 of 1000. And you may know that 1000 is 10 times 10 times 10, 10 to the 3. Basically, for powers of 10, you just count the zeros, right? 1, 2, 3, that's 10 to the 3. Once you do that, of course, cancel, cancel, and the answer will be 3. Now, if you were stuck with these, you could have done them on a computer. Nothing would have prevented you from doing that and getting the right answers. You would have simply, like for this first one, just erase it. You could have typed this in as log 6, and then 1 over 6 to the 5. And it'll just tell me 5, I'm sure. Or negative 5, right? Yeah. So you can make a computer do it. You type it incorrectly. Okay. Next, combine the following into a single logarithm. Use log properties from the in-class handout. So there's basically just 2 properties here. Well, 3 properties here that you need, right? So there's this one, like a log, like let's say a to the b. You can take the b down in front of a log. That's a rule. That's one of the rules. Another rule is that if you have log AB, that's the same as log A plus log B. And then finally, log A over B is log A minus log B. Kind of ran out of room there. So we're applying these rules basically starting with this type of thing, going to this type of thing, in order to try to consolidate these logarithms into one single logarithm. So the first thing you want to do is apply the first property to get any coefficients like this 3 up as an exponent, right? So a coefficient here can be brought up as an exponent on the A. So this can be moved here. So this 3 can be moved as an exponent on the y. So this is log 5, 7 plus log 5 y to the 3. That's the property, minus log 5, 4. So once you have that, then we basically just want to apply these properties. So anything that's being added, like the log A and the log B, ends up like this, multiplied together. Anything that is subtracted, like this log B, then the B ends up in the denominator when you apply this identity. So when you look at this right here, if I just think about like numerator, denominator, so like N for numerator, D for denominator, then like there's a plus here, right, that you don't see, but it has it. So the 7 would be in the numerator, and then this is also a plus. So the y to the 3 would be in the numerator. This is a minus, so this 4 would end up in the denominator. And when you apply those log rules, we're going to have one log 5, and then a fraction. And in the numerator, we have the 7 and the y to the 3. So 7y to the 3. And in the denominator, where this negative is, we have the 4. So the 4 would go down there. That is how you would do it. Okay. Now, the next problem uses the exact same properties, but backwards, right? Like if you think about it, you could have started with this, used the properties to split it up like this, and then used the property to bring the 3 down in front, and then you'd end up with this as your last step, right? Well, that's exactly what we're doing here. This is a very similar problem to this, except backwards. So the first thing to do is to split this up, and you just have 3 things here. So we've got just simply this, and this, right? The x to the 2, the y to the 5, and the 17. And we split that up into 3 logs then. So natural log x squared plus natural log y to the 5 minus natural log to the 17. Not to the 17, natural log of 17. So the 2 that were on top get plus, plus, and the one that's on the bottom gets a minus. If there were multiple things on the bottom, they would all get a minus. There's just one here. So that's our first identity. And then we apply this rule here. Any exponents need to come down in front. That's what they mean when they say simple log terms. No exponents should be allowed. So we just apply that rule for the exponents to all of them where it applies. So you take the 2 down in front and get 2 ln x plus, then we have an exponent 5 on the y. So we take the 5 down in front, 5 ln y. And then the 17, I don't see anything to do, so we'll just leave it at 17. And that's our answer. Simple log terms. What is this? Solve for x. So there weren't very many of these in the homework, and that's why I wanted to make sure that they were here. And there's a couple ways to do this, and I'll show you. It all boils down to this idea. Trying to zoom in here. A log of an exponential cancels out and leaves you with the result. Or an exponential of a log cancels out and leaves you with what's inside. But there are a few different ways to do this. So one way would be with, I'll say log 7, because this is a 7, and the other one, I'll just do a natural log. So there's going to be 2 different ways here, and we'll see we'll end up with the same answer. So if we start with this, 7 to the x equals 50. And then we take the log base 7 of both sides. You would have log base 7, 7 to the x, equals log base 7 of 50. Now, on the left-hand side, the log base 7 and the 7 exponential cancel out and leave you with x. On the right-hand side, nothing cancels out, so you just get log 7 of 50. Okay, now the problem with this is you don't have a log 7 button on your calculator. This is technically the correct answer, but you can't just type that in and get a decimal on your calculator without using the change of base formula. If you do use the change of base formula, what this would be log or ln, I'll say ln 50 over ln 7. That's with the change of base formula. So you do ln 50 and then ln 7. And these are the same number. So that's one way to do it. Now, the other way to do it, I said, was with a natural log. So you could have, instead of taking log 7 of both sides, we could have started here, 7x equals 50. And then you could take ln of both sides. So ln 7 to the x equals ln 50. Um, but the problem is if you do an ln, the natural log is base e. So base e log does not cancel out an exponential base 7, right? This is base e, this is base 7. They don't cancel each other out. So it's not quite the same. But what you can do is we can do something with that exponent, right? Don't we know that you can take the exponent down in front? So what you do is you apply the log rule that says this can come down in front. And you get x ln 7 equals ln 50. And from here, solving for x is easy because you simply divide both sides by ln 7, and you get x is ln 50 divided by ln 7. And this right here is exactly what we had over here. So it doesn't matter how you solve it. There's multiple ways, and you'll still get the same answer. Okay, so I just wanted to show you that there are two different ways to do that. And there they go. All right. Now this one is a logarithmic equation. So you still need to remember that a log and an exponential cancel each other out. In this case, this is base 5. So we will need an exponential base 5. So we exponentiate, as we would say, both sides. So we're basically going 5 to the entire thing here. Log 5x equals 5 to the negative 1. Okay, so we exponentiate both sides. And the reason we do that is because we know that an exponential base 5 cancels out a log base 5. And will just leave us with the x. And it's 5 to the negative 1. So like that's it. We essentially did the whole thing there. Of course, 5 to the negative 1 is 1 over 5 to the 1. So x is 1/5. Okay. So easy enough to do those by hand. It's all down to the basic definition of a logarithm, which is it's the inverse of the exponential. So log base 5 is inverses with 5 to the x. All right. Next question. So we got a couple Half-Life problems. I just looked up half-lives of things. So these should be the correct half-lives, but don't ask me what they are. Like erbium 160. What is erbium 160? No idea. Probably it's something that you never have 500 milligrams of. It's probably something really small quantities. But anyway, doesn't matter. We can still do this. So the key for these half-life problems is understanding that all of the half-life problems have A equals A0 e to the kt as their like basic equation that governs them. And the k is negative ln 2 over the half-life, as we learned in class. That saves you a lot of time knowing those equations, right? So when we see this problem here where they tell me the half-life of erbium 160 is 1.191 days, then I know that I go, okay, the k is negative ln 2 over 1.191, right? That's the k. And then also they say if 50 milligrams is present now, well, that's the starting amount of erbium 160. So that must be the A0. So if I go ahead and I write out my equation, I can fill in the K and the A0 and I get, so the equation we're going to use is A equals A0, which should be 500, the starting amount, e to the K is negative ln 2 over 1.191 t. So that's not the answer to the question, that's just the equation we use, right? So you fill in the A and you fill in the K. Now the question is, how much will be present in 60 days? So they want us to plug in t equals 60, and calculate how much is left, right? Because we're starting with 500 milligrams, but it's decaying, right? Because it's a half-life for radioactive decay. We have 500. After 1.191 days, we're going to have 250, right? Half. After another 1.191 days, we're going to have like 125, and so on. So after 60 days, a lot of it's going to be gone. How much? Well, we just plug a 60, t equals 60 in for t here, and we get a calculation. The amount left will be started with 500. This is our half-life stuff. I keep writing a 9 there instead of 191, 191. And then your t is going to be 60. And so we just punch this into a calculator and we're going to get a number. I'll do this one on computer instead of a calculator. So what do we have? 500. You can put the time symbol or just e to the parentheses. Inside the e, I have negative ln 2 divided by 1.191 times 60. All of that is in the numerator. So see how when I put that parentheses in, it matches up with the one on the beginning of the E. Everything I just typed there needs to be in the numerator. So we do that, hit enter, and you can see that I typed it in right. Notice that the Wolfram Alpha says log2 instead of ln2. That's just how Wolfram Alpha types it in. Okay. Is it really so small? I guess it is. 60 days is 30 half-lives. Okay. So it is what it is. 60 days is a long time, so we'll just write it 3.418. And this is times 10 to the negative 13, and that would be milligrams. And it's milligrams because that's what the original 500 was milligrams. So the units did not change. So that's a teeny tiny amount. So after 60 days, it's basically all gone. Decayed. Okay. Next question. This is going to be very similar, just different numbers. So half-life of fermion is 3 days, right? So when you see that the half-life is 3 days, we know that the K is negative ln 2 divided by 3 days. Okay, so our equation is A equals A0. How much do we start with? Start with 2 milligrams, so that's A0. So I'll fill it in. Right, we're doing A equals A0 e to the kt again. So A0 is 2. K is negative ln 2 over 3. T is T. So here's our equation. And then what do we want is a slightly different question than before. The question is, how long will it be before only 0.01 milligrams is left? So they didn't give me a T, right? On the previous problem, they gave me the T equals 60 days, and I calculated the A, which was the amount left. What they're doing now is they're doing the opposite. They're telling me how much is left, and they want me to calculate how long, which is a time, right? There's only two variables left here, time and an amount. So either they tell you the amount and ask for the time, or they tell you the time and they ask for the amount. So in this case, this is the A. It's an amount. So we fill that in. We get 0.01 equals 2e to the negative ln 2 over 3t. and we have to solve this for t. So if you are solving this for t, let me just write it again. If you are solving this for t, the first thing to do is going to be to divide both sides by 2 to get rid of the 2 in front of that exponential. So we're going to get 0.01 over 2 is going to be 0.005, I think, equals e to the negative ln2 over 3t. Then we want to get to the t, you need to undo an exponential e. The way to get rid of an exponential we have already talked about. We should take ln of both sides. So you're going to get ln 0.005 equals ln e to the negative ln2 over 3 t. The point of doing this is that the natural log and the exponential cancel, right? Because they're inverses. So you end up with ln 0.005 equals just negative ln2 over 3 times t. We're trying to solve for t. So we want to get rid of the ln2 over 3 part. So the way you would do that is just multiply both sides by the reciprocal. That should be a 3, not a 5. Multiply both sides by the reciprocal of what's there. So negative 3 over ln2 times negative 3 over ln2. On the right-hand side, right, 3's cancel, ln2's cancel, negatives cancel. So we just end up with t. On the right-hand side, we have what we have, right? Negative 3 over ln2 times ln 0.005. But we can just type this in again on a calculator or a computer and get this number. So this is what we're trying to type in. Negative 3 divided by ln 2, not ln, ln 2 times ln 0.005. Enter. And it says t equals 183.4 ish. Now, what did I calculate? So what we were doing was the half-life is 3 days. And we're saying if you start with 2 and we want to go all the way down to 0.01, how long will it take? And the answer is 183.4 days. So what this looks like, if you think about it on a graph, is like this. So you start out with 2, that's milligrams. Is it? Yeah. And then it decays, like gets really close to 0, right? And then the idea is somewhere down here you have 0.01 milligrams. And if you come over here to wherever it hits, and then you come down here to see what the answer is, it's 183.4. So this is time, and this is like the amount. And so what we were calculating was number of days. Okay, so yeah, so that was Half-Life. Finally, we're on to the last topic, right? So the last topic is going to be systems of linear equations. And, you can solve these with any method you want. Any of them is going to be okay. And yeah, so let's go ahead and get started. So actually for the first one, we're not solving it. I just say determine whether 4 comma negative 2 is a solution. And the way you determine if it's a solution is you plug it in for x and y. So you plug in x equals 4 and you plug in y equals minus 2 and you see what you get. If they're true, then it's a solution. So let's do it. So let's put those in for the x and the y here. We have 4 for x plus y, which is -2, equals 2, question mark. And then the other one is 2 times x. X is 4. 2 times 4 minus 3 times y. Y is -2, equals 10, question mark. I don't know if that's true. And then you work these out. So like this first one, you just do 4 minus 2. 4 minus 2 is 2, equals 2. So that's true, right? Left side equals the right side. Here we've got 2 times 4 is 8. And then we have minus 3 times -2. Well, minus 3 times -2 is going to be plus 6. Plus 6 equals 10. So 14 equals 10. That's actually false, right? So what that's telling you is that this 4 comma -2, this 4 comma -2 was a solution to this top equation, but it is not a solution to this bottom equation. So overall, it's not a solution, right? So we just say for -2 is not a solution, right? Because the second equation is not satisfied, right? This one was false. Okay, so that's just checking if something is a solution. It's not that hard. A little bit more work is going to be solving these. So I say find the solution if it exists. Use any method. Probably going to use a couple different methods on these. For starters, we could use graphing. So if I open up a web browser here, and let's just go over to desmos.com, graphing calculator. And if I want to graph these, that's easy to do, right? Let me make this a little bigger. If I want to graph these, that's not that hard to do. We just say 3x plus 2y equals -3. There's our first equation. The other one is going to be, let's see here, y minus x equals -4. So there's my two equations. They do cross at a certain point. So there is a solution. So let's zoom in, right? So the solution is right here. And can we read that? It says 1, -3. 1, -3. I think I could have made it bigger. Hold on. So is that easier to see? 1, -3. I don't know if that's bigger or not. But anyway, 1, -3 is what we saw. So we just did graphing. And we got 1, -3. Okay, so that's one way to get the answer. Another way to get the answer is going to be substitution. So substitution is like what we did in class on Wednesday. So let's try substitution. So for substitution, you look at your two equations and you solve for one of the variables in one of the equations. So I will solve for y in this equation. The reason I'm going to do that is it looks very easy, right? If I'm trying to solve that for y, I just do plus x, and I get y equals plus x, -4 plus x, right? So I've got I've got this solved for y now. Then what you do is you take that answer and you plug that answer, you substitute that into the other equation. So sub into other equation. So the other equation is 3x plus 2y equals -3, right? But the idea is y is actually equal to -4 plus x. So you fill in the -4 plus x, which is equal to y, in for this y that we've got here on the bottom. So we've got 3x plus 2 times y, but y is minus 4 plus x equals minus 3. So then we need to solve this for x. Solve for x because x is the variable that's in there. So we've got to multiply this all out here. So looking at the bottom equation, we've got 3x plus 2 times negative 4 is actually going to be minus 8. And then 2 times x is going to be 2x, and then equals minus 3. So we're trying to solve this for x still. We should combine our x's. We got a 3x and a 2x. So add those together, we get 5x minus 8 equals negative 3. Again, we're solving for x, so let's just keep going. We should add 8 to both sides. So plus 8 plus 8. I get 5x equals 5. Then I should divide by 5. I'm going to get x equals 5 over 5, or x equals 1. Okay, now you've got one of the numbers we need. So, okay, half done, right? Once you have one of those numbers, you take that number and you have to plug that into one of the other equations. So now plug in this case, we found x equals 1 into either of the original equations. There are other places where you could plug it in as well, but I'm saying the original equations. So easiest one is going to be the second equation, right? So I've got y minus x equals minus 4. Go ahead and put x equals 1 in there, and you get y minus 1 equals minus 4. I wrote minus 5 for some reason. And then if you're trying to solve this for y, plus 1, and you get, what do you get? You get y equals minus 3. So then you combine this information, x equals 1, y equals minus 3, and you get for your answer, well, x equals 1, y equals minus 3, or 1 comma minus 3, right? And of course, that's what we got from graphing, but doing the substitution work was what we did here. Okay. Now, yeah, so that was substitution. On the second one here, again, you could graph it, right? So we can come over here to Wolfram Alpha, and we can just type this, not Wolfram Alpha, Desmos, and we can just type this in here. I was trying to delete that. It wasn't deleting. Okay, we can just type this in. Just, what do we got? 5x minus 4y equals 10, and then 3y plus 4x equals 23.5. I don't really see that on here. Where is the equation? Oh, up here. Right, so they do intersect, so there's a solution. They intersect right here. Now, looks like it says 4 comma 2.5. That's going to be the answer, 4 comma 2.5. But I'm going to solve this with a different method as well. So 4 comma 2.5 is going to be the answer. I'm just going to write it. Okay, but we're going to do a different method. We're going to solve this with addition. So this is what we did on Friday. So you can do the previous method as well. You could do substitution. It's just harder to solve for one of these variables. So addition is this idea. So you're actually allowed to add an equation to another equation. So I'll write out what you're allowed to do. You are allowed, let me just number these, 1, 2. You are allowed to multiply 1 and 2 by any number. And you can do a different number for each one. You can multiply by any number and the equation is still valid. Another thing you're allowed to do is you are allowed to add an equation to another equation to get a third equation. So you're allowed to add an equation to another equation to get a third equation. Okay. And if you're smart, which you are, right? If you are smart, you can add them up in a way that cancels out a variable. And eliminating a variable will let you solve for the remaining variable. So when you look at this equation here, one thing you should notice right away is that you've got a minus 4y. Oh, I'm dumb. I changed the, it's okay, but I didn't line up the variables. Right? I was going to say you have a minus 4y and a plus 4y, but that's a lie, right? You have minus 4y and you have plus 4x. So first of all, one thing to do is don't write it this way. Let me just rewrite this. So this is not wrong, but I don't like writing it this way. I'm going to need it written so that it lines up with the other one. So I should write the 4x first and then plus 3y. And then equals 23.5, just so it matches the other one. Okay, so I'm still going to do addition here. Okay, so this is going to be a little complicated, maybe. So here's my idea. Looking at, get rid of that and get rid of that. So looking at these two equations now, I see this has got a 5 and this has got a 4, right? So 5 and 4 both go into 20, right? So I'm just telling you what I'm thinking. Step A, that's an A. I just noticed 5 and 4 go into 20. I just noticed that, right? So what I'm going to do is I'm going to multiply the first equation by 4. The reason I'm going to do that is because when I multiply the 5 here by a 4, it's going to turn into a 20. That's why. Then what I'm going to do at the same time, I'm going to multiply the second equation by 5. By 5 because 4 times 5 will be 20 again. I'm trying to make a 20 here. But I don't actually just want a 20, I want a negative 20. So instead of multiplying it by 5, I'm going to multiply it by minus 5. Okay? So that's my idea. I'm allowed to do that because, trying to zoom out, if you read, we are allowed to multiply 1 and 2 by any number. So I'm going to multiply 1 by 4 and 2 by negative 5. Let's do it. So if I do that, let me just rewrite them. I've got 5x minus 4y equals 10. And the other one is 4x plus 3y equals 23.5. And what I'm going to do is multiply this first one by, what did we say, 4. And I'm going to multiply the second one by 5, actually minus 5. Okay? And then we'll see what we get. So the result will be what I write next. So when I do that, I have to distribute this 4 all the way across. So 4 times 5x is going to be 20x. Then I've got 4 times minus 4, which is going to be negative 16y, then equals. And then I have 4 times 10, which is going to be 40. Okay, so that's the first equation multiplied by 4. Then I'm going to take the second equation, take the second equation and multiply it by negative 5. But let's do the same thing we just did. So we've got -5 times +4 will be -20. That's the whole point. That's what I'm trying to do here. Then I've got -5 times +3y. That'll be -15y. And then I've got -5 times 23.5. I don't know what that is. I need a calculator. I'm just going to do it. 5 times 23.5 is 117.5. So I've got -117.5. Okay. So I just multiplied those. Now, then what I'm going to do with these is I'm going to add them. So the next thing is, that was part A. Part B, add the equations. Not the original equations, the equations as we have them here. So I'm going to duplicate that so I can just move them up here. So we're just going to add these together. So we just put a plus, line under it, let's add them together. So when we add these, the idea is because we made a 20 and a -20, when you add 20 and -20, 20x minus 20x is going to be 0 here. Trying to write and failing, 0. So this plus this cancel out. Now the rest of this we just have to work out. So like -16y plus -15y. Well, -16y plus -15y, -16 plus -15 is -31y. And then on the other side of the equal sign, we got 40 plus -117.5. So that's another job for the calculator. 40 minus 117.5 is 77.5, -77.5, -77.5, like that. And then from there, what I would like to do is solve this for y. So let's just solve for y. So I've got, what do I have? I have -31y equals -77.5. So we just divide by -31, it looks like. Y is -77.5 over -31. The numbers look weird here. I'm a little bit concerned that I made a typo somewhere. I did not. It's okay. So you divide this, you get y equals 2.5. That's one of the ones we need. And then for your last part, it's going to be the same as the last part on the previous problem, right? Like once you have like one of the numbers, you can plug that number into one of the other equations. So like I can take this y equals 2.5 and plug it into like this first equation, for example. So let's just say d plug y equals 2.5 into any of the equations that you've got, any equation to get x, So one of the other equations was 5x minus 4y equals 10. So 5x minus 4y equals 10. So you put in the 2.5. So you're going to get 5x minus 4 times 2.5 for y is 10. Kind of out of space, but I'm going to keep going. 4 times -2.5 is 10. So this says 5x minus 10 equals 10. Add 10 to both sides, you get 5x equals 20. Divide both sides by 5, you get x equals 20 over 5, which is 4. So you've got x equals 4, y is 2.5, which x equals 4, y is 2.5 that we got from graphing. Okay, so that was addition. You could have solved that with substitution as well, and it would have worked fine. But we did addition. Okay, so that's your practice test. Again, just the real test is going to be open basically all of next week. It's going to be multiple choice, which should make it a little bit easier than this, and a little bit shorter as well. So that is it for now. Good luck with any studying you're doing. If you need to meet with me for something, let me know.